Our solar system is a place of incredible diversity, filled with planets that each have their own unique characteristics and mysteries. Each planet has its own story to tell, from the gas giants with their swirling storms to the rocky terrains of the inner planets. Venus, our closest neighbor, is a world of intense heat and a thick, toxic atmosphere. Its surface is shrouded in clouds of sulfuric acid, making it a challenging place to study. But beneath this hostile exterior lies a fascinating secret. Venus is home to more volcanoes than any other planet in our solar system. These volcanoes have shaped the planet's surface in ways that are both dramatic and beautiful. Imagine a world covered in volcanic features, where the landscape is dominated by the remnants of ancient eruptions. Vast plains of solidified lava stretch for miles, punctuated by towering shield volcanoes and strange pancake-shaped domes. These formations are a testament to the planet's volcanic past. This is the reality of Venus, a planet where volcanic activity has played a dominant role in shaping its landscape. The surface is a mosaic of volcanic features, each telling a part of the planet's history. The sheer number of volcanoes is staggering. Venus's surface is dotted with thousands of volcanic structures, each one a potential window into the planet's geological past. Scientists have identified over 1,600 major volcanic features on Venus. These include massive shield volcanoes, extensive lava plains, and unique formations not seen anywhere else in the solar system. However, when we consider smaller volcanoes, the total number could exceed 1 million. This makes Venus an incredibly active planet, geologically speaking. This abundance of volcanic activity makes Venus a prime target for scientists eager to understand the forces that shape planets. By studying Venus, we can learn more about the processes that drive volcanic activity on Earth and other planets. Venus's volcanoes are not just numerous, they are also incredibly diverse. The variety of volcanic features on Venus is unmatched, offering a unique glimpse into the planet's geological history. From towering shield volcanoes to bizarre, pancake-shaped domes, Venus's volcanic landscape is a testament to the incredible power of geological processes. Each type of volcano tells a different story about the planet's past. Venus's volcanic landscape is a testament to the incredible power of geological processes. The planet's surface is a dynamic and ever-changing environment, shaped by the forces of volcanism. In the next section, we will delve into the details of this unique volcanic world. We will explore the different types of volcanoes found on Venus and the geological processes that have shaped this fascinating planet. Venus is often called Earth's sister planet due to their similar size and composition. However, the surface of Venus is a far cry from our own planet's diverse landscape. The Venusian surface is a scorching hot, dry world, dominated by volcanic features. Imagine standing on the surface of Venus. The air is heavy, thick with carbon dioxide and shrouded in perpetual twilight. The ground beneath your feet is a desolate expanse of volcanic rock, shaped by eons of eruptions. Across this alien landscape, vast plains of solidified lava stretch towards the horizon. These plains are the result of countless volcanic eruptions, where molten rock flowed across the surface, reshaping the landscape. Rising from these plains are volcanic mountains of various shapes and sizes. Some of the most impressive features are the shield volcanoes, similar to those found in Hawaii and Mars. These towering structures are formed by the gradual buildup of lava flows over millions of years. Their slopes are gentle, and their summits often contain vast calderas, collapsed depressions marking the remnants of past eruptions. The volcanoes on Venus exhibit a remarkable diversity, reflecting the complex geological processes at play. While shield volcanoes dominate the landscape, other more peculiar volcanic formations add to the intrigue of Venus's surface. One such formation is the Pancake Dome. These dome-shaped structures, much larger than lava domes on Earth, are thought to be formed by highly viscous, silica-rich lava erupting under Venus's immense atmospheric pressure. The lava, too thick to flow far, piles up around the vent, creating these unique pancake-like formations. Adding to the volcanic variety, scientists have also identified structures resembling giant ticks on Venus's surface. These unusual features consist of a central dome surrounded by a ring of fractures and radiating ridges. Their formation is still debated, but they likely represent a type of volcanic eruption unique to Venus. The diversity of volcanic features on Venus is a testament to the complex interplay of factors that shape planetary surfaces. The high atmospheric pressure, the composition of the lava, and the underlying geological processes all contribute to the unique volcanic landscape we observe on our sister planet. Section 4. Active fury, signs of ongoing volcanism. While Venus might seem like a static, hellish world, there is growing evidence to suggest that volcanic activity is not just a thing of the past. In fact, the planet's surface is dotted with numerous volcanic features, including vast lava plains, towering volcanoes, and extensive rift valleys. These features hint at a dynamic geological history, one that may still be unfolding today. Scientists have observed several indicators pointing towards ongoing volcanism, hinting at a planet still very much alive beneath its thick veil of clouds. The dense atmosphere of Venus, composed mainly of carbon dioxide with clouds of sulfuric acid, makes direct observation challenging. However, advanced satellite imagery and data analysis have provided crucial insights. One of the most compelling pieces of evidence comes from the detection of sulfur dioxide in Venus's atmosphere. This gas, which is typically released during volcanic eruptions, has been found in varying concentrations, suggesting that it is being replenished by active volcanic sources. Sulfur dioxide is a gas commonly released during volcanic eruptions. On Earth, we see similar emissions from active volcanoes which release this gas along with other volcanic materials. The presence of sulfur dioxide in Venus's atmosphere, especially in fluctuating levels, is a strong indicator of ongoing volcanic activity. Its presence in the Venusian atmosphere, particularly in fluctuating levels, suggests that volcanoes are still spewing out gases from below. These emissions could be contributing to the planet's thick, toxic atmosphere, which is a key factor in its extreme surface conditions. Further evidence comes from thermal anomalies or hotspots detected on the surface. These anomalies are areas where the surface temperature is significantly higher than the surrounding regions, indicating the presence of heat sources beneath the surface. These hotspots, often located near volcanic features, indicate areas of unusually high temperatures, possibly caused by molten rock close to the surface. The detection of these thermal anomalies suggests that there may be active lava flows or magma chambers beneath the surface, contributing to the planet's ongoing geological activity. These anomalies could be signs of active lava flows or magma chambers cooling beneath the surface. The presence of such features indicates that Venus is not a dead planet, but one that is still geologically active, with processes similar to those seen on Earth. Specific volcanoes such as Mat Mons, Oza Mons, Sapas Mons, and Idun Mons have shown particularly strong evidence of recent activity. These massive volcanic structures, some of the largest in the solar system, are key sites for studying Venus's volcanic history and current activity. These volcanoes exhibit a combination of features, including thermal anomalies, radar-bright flows, and changes in their surrounding terrain, suggesting that they may have erupted in the recent geological past. The study of these features provides valuable insights into the dynamic processes shaping Venus's surface and helps us understand the planet's complex geological history. Section 5. Resurfacing power volcanoes and Venus's youthful appearance. Despite its ancient origins, Venus boasts a surprisingly young surface. This is quite intriguing when you consider that Venus and Earth are often referred to as sister planets due to their similar size, mass, and proximity to the Sun. However, their geological histories have diverged significantly. Unlike Earth with its constantly shifting tectonic plates, Venus lacks plate tectonics. On Earth, these tectonic plates are responsible for the creation of mountains, earthquakes, and the recycling of the planet's crust. The absence of such a system on Venus raises the question of how the planet manages to renew its surface. So, how does a planet without plate tectonics renew its surface over geological timescales? This question has puzzled scientists for decades. The answer lies in a different kind of geological activity that is equally fascinating and powerful. The answer lies in its intense volcanic activity. Venus is home to numerous volcanoes, some of which are much larger than those found on Earth. These volcanoes have played a crucial role in shaping the planet's surface. Volcanoes act as planetary recyclers. They bring molten rock from the planet's interior to the surface, where it cools and solidifies, creating new landforms and covering older ones. This process is essential for the renewal of the planet's surface. They bring molten rock from the planet's interior to the surface, where it cools and solidifies, creating new landforms and covering older ones. This continuous cycle of volcanic activity ensures that the surface of Venus remains relatively young and dynamic. On Earth, plate tectonics play a major role in this process, but on Venus, volcanoes take center stage. The lack of tectonic plates means that volcanic activity is the primary mechanism for surface renewal. The sheer number and scale of volcanic eruptions on Venus have effectively resurfaced the planet multiple times throughout its history. These eruptions are not just occasional events, they are a constant and defining feature of Venus's geological activity. This ongoing volcanic activity explains why Venus's surface appears relatively young, with fewer impact craters compared to other celestial bodies lacking an atmosphere. The constant resurfacing by volcanic activity erases the evidence of past impacts, giving Venus its youthful appearance. The exact mechanisms by which Venus loses its internal heat and fuels its volcanism are still under investigation. Scientists are using data from various missions and advanced computer models to understand these processes better. One leading theory suggests that heat escapes through areas called coronae, large circular features on the surface characterized by concentric rings of ridges and troughs. These coronae are thought to be hotspots of volcanic activity. These coronae are thought to be areas where hot plumes of mantle material rise from deep within the planet, causing volcanic activity and resurfacing. This process is similar to the mantle plumes found on Earth, which are responsible for creating volcanic islands like Hawaii. Understanding Venus's volcanic activity not only helps us learn more about our neighboring planet, but also provides insights into the geological processes that can occur on other rocky planets. As we continue to explore Venus, we may uncover more secrets about its dynamic and youthful surface.